E1.
But actually, electricity consumption is only about 1/6 of my carbon footprint. So even if I manage to halve our electricity consumption in the house, gee, it's like it's going on a long hike with blisters on your feet, and you've realised that you've only gone 1/6. It's a 6-day hike, and it's only halfway through the first day. God, cars. Well, David Mackay has a nice way of dealing with quantifying all these things. He stacks these things up in little blocks. The average person in this country uses 40 kilowatt hours per day driving their car. That includes holidays, it includes business travel, it includes everything. I don't want to go into too much detail, but what I want to try and do now is just to stack things up so you get a feel for how big things are. If we then, there's our 40 kilowatt hours per day for the car, that's consumption. On the right-hand side here, I'm going to start stacking up some green blocks to think, how can I start generating power? And how much can I get? Well, wind. We know that the Wembley Stadium worth per person, 4,000 square metres. Well, let's suppose we're going to use 10% of the country. That's 400 square metres per person. It turns out we can work out what a wind turbine will produce, about 2 watts per square metre. So if you then multiply the 2 watts by 400 square metres, you get 800 watts. If you then convert that into kilowatt hours per day, this is what wind can produce. Now, if we did that, this is what wind could possibly produce in the UK, if we gave up 10% of the country to wind turbines. If we actually did that, we would be producing twice as much wind power as the whole world is currently producing. 50 times what Denmark is producing, 7 times what Germany is producing. That would be a dramatic increase in wind power for the world, and certainly for the UK. And it still doesn't even match the amount of power we need to keep our cars going. Okay. Flying. Well, it's absolutely fantastic what's happened the last week or so. It's made people think, look how big this is. Flying, 30 kilowatt hours per day. Okay, this is average, which means that actually for the likes of most of us, we're above average in this room. If you think of what the average salaries are in the UK, we're all above average. We can afford to fly for holidays. A lot of people can't. We're the ones who are doing this. So this is average per whole of the UK population, but actually, averaged amongst those who do fly, it's much bigger. So our carbon footprints are very much bigger because we fly. If you just halve the amount of flying, you're going to do wonders for your carbon footprint. So let's try and put another block on the right-hand side here. Solar. Well, let's suppose we were to cover every south-facing roof in the country with solar power. Okay, well, that's how much we can do. You multiply 10 meters squared per person, multiplied by the power from the sun per square meter, and you get this figure. That's not very big. What about if we were to do things on a bigger scale, have huge amounts of solar panels? Well, can we cover the countryside with these things? Well, if we do, we cover 10% of the country with solar power. You can probably put those underneath your wind turbines. That's not too bad. Okay, so we can actually get quite a lot out of photovoltaic farming, if we're prepared to do that. There's another block up here, biomass. If we were to plant lots of crops, 10% of the country covered with bio crops. Well, on the other side here, we've got heating and cooling. Another big problem is we love our houses to be warm. Can you feel how warm it is in here? Well, in the old days, it would have been cold. and the warm bit we would have had between our nice woolly jumper and our skin. But we've decided that we don't like doing that. We like the whole place to be warm, so we don't need that woolly jumper. Well, that's the result. This huge, great chunk of CO2.
E2. Extract 1.
So this is average per whole of the UK population, but actually, averaged amongst those who do fly, it's much bigger. So our carbon footprints are very much bigger because we fly. If you just halve the amount of flying, you're going to do wonders for your carbon footprint.
Extract 2.
What about if we were to do things on a bigger scale, have huge amounts of solar panels? Well, can we cover the countryside with these things? Well, if we do, we cover 10% of the country with solar power. You can probably put those underneath your wind turbines. That's not too bad. Okay, so we can actually get quite a lot out of photovoltaic farming. If we're prepared to do that.
E3.
Now, if we did that, this is what wind could possibly produce in the UK, if we gave up 10% of the country to wind turbines. If we actually did that, we would be producing twice as much wind power as the whole world is currently producing.
E4.
Let's keep piling these things up. We could do hydro for the UK. Well, unfortunately, that's not very helpful. UK is not mountainous enough. You can do a nice sum, calculations of what we really need to do. So just try and work out what is the average height of the UK and what's the average rainfall, and then how much energy can you possibly get by allowing the water to fall down from that average height down to the sea. And then multiply by that by say 10%. So extract 10% of that, and that's the figure you get. It's unfortunate, but that's the way it is. Light bulbs. Everyone loves to switch off their light bulbs and put in energy-efficient light bulbs, but unfortunately, that's a little bit that you're playing around with there. So by all means do it, but just bear in mind that that's only a tiny part of the picture. Other things, of course, we're told to unplug our phone chargers, we're told to put our TVs on, unplug the TVs and turn off the computers and so on, but still, unfortunately, that is that little red blob there. So compared with the car, the flying and the heating and cooling, it's not a big deal. On the right-hand side, I've added a few more offshore wind, deep offshore wind. So actually, this right-hand side's looking quite good, except that I put on wave power there. That's you can do some sums to work out how much energy comes into the UK from waves. We've got a few more consumption things to think about. Food. We actually use quite a lot of energy in producing and consuming food. So that goes up on the left-hand side. If you're a meat eater and you drink milk, that's a bit of a problem. Mainly because cows produce methane, and methane is a pretty potent greenhouse gas as well as CO2. So if we could get rid of that problem, that would be good. So the meat eaters are up around 12 kilowatt hours per day. That's minimum. Vegetarians 4, vegans 3. If you own a cat, 2 kilowatt hours per day per cat. If you have a dog, 9 kilowatt hours per day per dog. A horse, 17 kilowatt. They all add up. So that's 17 for a horse. quite significant on this pile. Tidal power, that's quite a neat one. The tides that come in and out produce some energy. There's some good schemes for tidal power. Tidal stream power is quite an interesting one. That's having big undersea turbines, like wind turbines, but just water turbines. They're big engineering constructions, but it's certainly worth thinking about. Reliability and maintenance is a big issue. We could consider doing tidal, but that's going to give us this kind of figure up here. Barrages, the Severn barrage. This is a picture here showing this is the Severn estuary here, and we could put a dam in here and extract power from there. But if we can start thinking of using the whole of this coast or this coast to extract tidal power, there's any number of possibilities. On the right-hand side, on the left-hand side, stuff that we use. Well, this is actually, unfortunately, really another big one. The amount of junk that we accumulate. It's extraordinary how the stuff that we pay good money for, which we call goods when we buy them, and we then use them for a really relatively short length of time, and then they go up into the loft or into the garage and they become clutter. And then we put them out into the landfill and they become garbage. And when you actually look at them, they don't actually look much different. You know that fridge you see on the landfill site and the fridge you see in the shop? You'd actually be hard-pressed to find out what the difference was just by looking at it. Yet one is garbage and the other is goods. Once you add up all our stuff, the fact that we are addicted to buying things, we're addicted to our computers and a new computer every couple of years and a new suit every couple of years and a new car and a new refrigerator and a new kitchen. Well, that's a big thing. So unfortunately, this left-hand column has now crept up above the right-hand column. We'll stop building up these things, but this is a pretty good estimate then of how big our left-hand column is. It adds up to roughly 125 kilowatt hours per day per person. Now 125 kilowatt hours, we would remember 20 minutes of a kettle is a kilowatt hour. So it's 125 lots of 20 minutes of a kettle. So it's about 40 hours worth of a kettle boiling. So you'd have to have 2 kettles running continuously all day for your whole life to produce that amount, to use up that much amount of power. But we have a problem. The right-hand side looks good, apart from the fact that we are addicted to protesting and to complaining and to saying no. We don't want wind farms, we don't want all those things.